So, hello everyone, welcome back to Hasora Education. Today we will be solving 9702 Paper 2 Variant 3, but it's the October-November 2024 and the time allowed for this paper is 1 hour 15 minutes. So, let's begin. So, now we have the first question which says define acceleration. So, acceleration is the rate of change of velocity. This is the definition of acceleration. The second part says a small aircraft is flying horizontally at a speed of 42 meters per second at a height of 63 meters above the horizontal ground as shown in figure 1.1. So the aircraft drops a small parcel. The parcel is released from the aircraft at the instant shown on figure 1.1. Air resistance is negligible here. On figure 1.1, draw a line to show the path of the parcel as it falls from the aircraft to the ground. So we have to show the path of the parcel. So for example, this is the parcel that is being thrown from the aircraft. So this is the parcel, okay? This is the parcel. So it is going to follow the path of a projectile. It is going to be falling like this. So this is the path. So now calculate time taken from the instant of the release to the instant of the parcel reaching the ground. So now what we actually know is the vertical height, which is 63 meters. Do we know the time? No, we have to find the time. And what is the vertical component of the speed? So that is 0. Why? Because it is traveling at a speed of 42 meters per second horizontally. So there is no vertical motion here. So we know that the gravity is going to be 9.81 positive as it is falling downward. So let's apply the equation. S is equals to ut plus half at square. So S is 63 is equals to u is 0 into t plus half into 9.81 into the t square. So this becomes 63 into 2 is equals to 9.81 t square. So this becomes t square is equals to, let me grab the calculator. So 63 into 2 divided by 9.81 and the under root, this becomes 3.58 seconds. So this is 3.58 seconds, which is going to be rounded off to two significant figures. This becomes 3.6 seconds. So now calculate the vertical component of the velocity of the parcel immediately before it reaches the ground. So what we have to do is that we have to apply 2as is equals to v square minus u square to find the final velocity. Okay, we have to find the final velocity. So it is going to give us the vertical velocity. So it is 2as. So 2 into 9.81 into 63 into 0. So this becomes 2 into 9.81 into 63 and then under root. So this comes out to be 35.15 meter per second. So this is the velocity at which the the parcel is actually reaching the the ground. So now we have to find the vertical component of the velocity. So for example, if this is the track, like it is following this track, this is going to be the velocity 35.15. No, just wait a minute. This is going to be 35.15. This is the vertical component, okay? 35 point. You can also add 35.2, but we are going to maintain the two significant figures. So we are just going to be writing 35. So now this is 35.15, and the horizontal one will remain the same, which was 42. I believe, just let's check it. It is 42. So now let's find the resultant. As in the next part they have asked us the speed. So it is going to be v square is equals to under root, so also going to be under rooted, and this is going to be 35.15 square plus 42 square. Just let's find it out. The 35.15 square and 42.15 square, and then under root both. So this becomes v is equals to 54.76, which to two significant figures becomes 55 meters per second. So in the part 3 that we found was the vertical component, as we were using 2s is equals to v square minus u square, is gives you the the vertical component only. But in the fourth part, they have asked us about the, the the resultant velocity actually, which is the horizontal and the vertical combined. So now let's move on to the next question. The next question says state the principle of conservation of momentum. So the principle of conservation of momentum is for an isolated system, the total momentum before is equal to total momentum after. Or you can also write the total momentum is conserved. In the B part, they are telling us a ball X has a mass 240 grams and moves in a straight line on a horizontal frictionless surface with an initial speed of 16 meter per second. The ball collides with a stationary ball Y. So the ball Y is stationary, V is equals to 0, and that has a mass of 480. After the collision, the X is stationary as shown. So show that the speed of Y after a collision is 8 meter per second. So we know that the total momentum before is actually equal to total momentum after. So it is 240 into 10 power minus 3, just because it is in grams, and then into 16, and then plus 0 into 4 into 80 into 10 power minus 3, as it is stationary. So the ball X then becomes stationary to 14 10 power minus 3 into 0. You have to write it just to show that it is stationary, and the direction is the same, so we are going to be maintaining it as positive. So 4 10 power minus 3, let's just calculate it. 240 into 10 power minus 3 into 16, it becomes 3.84. 3.84 is equals to 480 into 10 power minus 3. It becomes 0.48 V. So now let's divide 3.84 divided by 0.48. So it comes out to be V is equals to 8 meter per second. So we have shown this correctly. Now they are telling us calculate the change in total kinetic energy of the ball due to the collision. So what we have to do is we have to first calculate the initial kinetic energy. So the kinetic energy initial was half into m. So we know that one of the ball was stationary, so it has no kinetic energy. So ball X was the only one which has kinetic energy initially. So it is 240 in 10 power minus 3 into 16 square. So this comes out to be 256 into 240 into 10 power minus 3 divided by 2. This comes out to be 30.72 joules, and then the kinetic energy final is equals to half into 480 into 10 power minus 3 as the ball x then comes to rest, and it is 8 square, so it becomes 64 into 480 into 10 power minus 3 and then divided by 2. So it becomes 15.36. So now we can easily calculate the change in the kinetic energy by subtracting it. So it is 15.36 joule final minus the initial. So it becomes 30.72 minus 15.36. So it comes out to be minus 15.36. The minus is just because the kinetic energy has decreased. So if you can also write it like this, and it is 15.36 joules. Now in the next part they are saying the collision in in the B lasts for the time of 2 meter per second. So in the C part these are saying that the collision in the B lasts for 2 meter per second, 2 millisecond actually. It is the time, so it is 2 millisecond, 2 into 10 power minus 3 seconds. Assume that the contact force between the ball is constant during this time. Determine the magnitude and the direction of the force exerted on the ball x by ball y during the collision. So now how can we find out the force? So the force can be found out by the change in momentum. You can take out the change of momentum of any one ball, for example x. The ball x actually changes from m into v minus u. So it is, let's just find it out. So ball x becomes 0 and the initial was 16 and its mass was 4, not 480, it was 240. 240 10 power minus 3 into 16. So let's just calculate it. 240 10 power minus 3 into 16. It comes out to be 3.84. This was the change of momentum, and then divided by the time, 2 in 10 power minus 3. So this is the force. This is the force. So 3.84 divided by 2 to 10 power minus 3. This comes out to be 1920 Newton. But rounded off two significant figures, it becomes 1900. So it is the force exerted on the ball x by ball y. So it is going to be towards for example, the ball x was here and the ball y was here. So, so it is x and this is y. So the force exerted on ball x by ball y will be towards the left. So the magnitude is 1900 and the direction is left, or you can also write towards the left. Compare the magnitude and direction of the force exerted on the ball y by the ball x during the collision with the answers in C1. No further calculations are required. So according to the Newton's third law, we know that the forces exerted on each other will be of the same magnitude and they will be opposite in direction. So we can write the force is opposite in direction and equal in magnitude. So this will be the answer. One mark for the opposite direction and the other will be for equal in magnitude. Let's move on to the third question, which says state the principle of the moments. So we have also tackled a similar question like this before. So the answer for this will be, just let me adjust the screen. So the answer for this will be, for a body to be in equilibrium, the sum of clockwise moment is equal to sum of anti-clockwise moment. Now in the B part they are telling us a rigid uniform beam rests on the pivot at its center as shown in figure 3.1. So this is the diagram. A load of weight 2.6 Newton is suspended from the beam as a distance of x from the pivot. A wooden cylinder of weight 4 Newton is suspended from the beam at a distance of 4 from the pivot. On the opposite side of the pivot on the load, the cylinder rests in a container of water, and the lower part of the cylinder is immersed in the water to a depth of h, where h is equal to 0.1 meter and x is equal to zero point 0.4 meter. The system is in equilibrium. Use the principle of moments to show that the upthrust U exerted on the water on the cylinder is 1.4. So here it is a very important concept here that they have already given us the x which is 0.4. So the x is 0.4 and the depth is also given to be 0.1 meter. So now what actually happens is that the weight of the cylinder is going to be acting downwards, but simultaneously the upthrust is going to be pushing it towards the up. So now when we take the moments, this is going to become the anti-clockwise moment and this is going to be become the clockwise moment. But here is a twist here that the clockwise moment due to the cylinder will be the weight minus the upthrust, but the weight will be more than the upthrust. So let's calculate it now. So clockwise is equal to anti-clockwise moments. So now clockwise was weight minus the upthrust into zero point 0.4 is equals to zero point 0.4 into 2.6 Newton. So weight we know was 4.4.0 Newton minus U into zero point 0.4 is equals to zero point 0.4 into 2.6 becomes zero point 0.4 into 2.6 is 1.04. So 1.04, 4 minus U is equals to 1.04 divided by zero point 0.4. So 4 minus U is equals to 2.6. This is 2.6 and this will become 4 minus 2.6. So this comes out to be 1.4 Newton. So this is the upthrust force here which we have shown as 1.4 Newton. Now the next part says the density of the water is 1 into 10 power 3 kg meter cube. So now calculate the area A of the cross section of the cylinder. So we have already found the upthrust which is rho GV. So upthrust was 1.4 Newton. They have given us the rho and then the gravity is 9.81. We will find the volume through this. So volume will be equal to 1.4 divided by 110 power 3 into 9.81. This comes out to be 1.4 divided by 9.81 into 1 into 10 power 3. So this comes out to be 1.427115189 into 10 power minus 4. So this is the volume. We know volume is equals to area times the length. So we know the length. So it will become 1.42 into 10 power minus 4 divided by the length which was zero point 0.1 as they have given us the height. So the area will become 1.42 into 10 power, or you can write it to significant figure as 1.4 into 10 power minus 3. Now the part C says the more water is gradually added to the container in B so that depth H is gradually increased. The length X is continuously adjusted so that the system remains in the equilibrium. So now let's have a look at the diagram above. So now what happens is that this height is going to increase. When this is going to increase, what will happen? The F up or the upthrust is going to increase, and this will cause the resultant net force to decrease, which is the way towards the downward. So as a result, what will happen that the clockwise movement will decrease. So to compensate that, what will happen is that we have to decrease the x. We have to compensate for the clockwise movement. We have to the decrease in the clockwise movement. We have to also decrease the x to decrease the anti-clockwise movement, so the system remains in the equilibrium. So that is what was being tested here. So for the start at the zero point 0.1 height, we were given the x was zero point 0.4, and when you calculate it, that the x becomes almost 0. What is the height? It comes out to be 0.29 here. So it is going to decrease and form a decreasing gradient line, and it is going to be a straight line from zero point 0.4 on the x-axis to 0.29 on the y-axis. So moving on to question number 4, the part A says define stress. So definition of stress is force. Stress is the force acting per unit area. Part B says strain. So what is strain? It is the ratio of the the stretched length to the unstretched length, or you can say it is the ratio of the change in length to the original length. The ratio of change in length to original length. Now in the part B they are saying that two y's x and y with the equal unstretched length of 0.84 meter are suspended from the fixed point that are in the same horizontal level. The lower ends of the wire are attached to a beam of negligible mass. The beam is horizontal and in equilibrium as shown. So the wire axis of from a metal has a Young modulus of 1.9 in 10 power into 10 power 9 pascals. So we have been given the original length was 0.84, just writing it here for convenience. So this was the original length, okay? And they have given us the Young modulus of the wire X. Wire Y is made from a different material, so it means that will have a different Young modulus. A load of weight 18 Newton is suspended from a beam at the point that is equidistant from the two wires. So this load causes the both wire to extend by the 0.47 millimeter. So now be careful here that they have given this in millimeters, so we have to be converting this into meters by multiplying it with into 10 power minus 3. So this is going to be the change in length, which is the same for both. So this becomes 0.47 10 power minus 3 meter, and they have given us the Young modulus. So now let's check what they are asking. So they are asking us to determine the cross-sectional area of wire X. So now we know the Young modulus. The Young modulus is, or I think we will use another method here. Just let's check it which quantities have been provided. So we know that the stress is equals to force upon area. Okay, so have they provided us with stress? No, they have not. They have provided us with the force of 18 Newton. So how are we going to be finding out the stress first? we are going to be applying the Young modulus. Okay, so the Young modulus is equals to the stress over the strain. So Young modulus was given. Let's check it. What was the value? 1.9 into 10 power 9 10 power 9 into the strain. So what was the strain? The change in length over the original length, 0.84 being divided on what was the change in length? 0.47 into 10 power minus 3. And this comes out to be the stress. Let's calculate it. So 1.9 into 10 power 9 into 0.47 into 10 power minus 3 and then divided by 0.84. So this comes out to be, let's calculate it again. I think there is an error. So 1.9 into 10 power 9 into 0.47 into 10 power minus 3 and then 0.84. So this comes out to be 1.063 into 10 power 6. So now we have been provided with the force, so 1.063 into 10 power 6, and it is being divided by the force to calculate the cross-sectional area. This moves towards here, and this is being divided by the force. So now let's find this. The cross-sectional area comes out to be 1.69 into 10 power minus 5. So we can write it as two significant figures as 1.7 into 10 power minus 5 meters square. So now in the second part they are asking wire Y has a greater diameter than the wire X. So now just be vigilant here that they are talking about the diameter, not the cross-sectional area. The cross-sectional area is actually pi d square by 4. Okay. Explain without the calculation whether the Young modulus of the metal from which the Y is made is less than, the same, or the greater than 1.9 into 10 power 9 pascals. So now let's just use the the formula for the Young modulus to just qualitatively check that is it greater or no. So the Young modulus will be equal to the stress over the strain. So so the strain has no effect here as it is going to be the same. So let's just compare it with the uh, with the with the stress. So stress is force upon the area. So we know that area is pi d square by 4. So now what happens when the diameter is increased? What will happen? The Young modulus will have to decrease. So this was the point here. So now let's write it here in the answer. So we can write the Young modulus is inversely proportional to the cross-sectional area, which actually makes is made from the diameter. So as the diameter is increased, the cross-sectional area increases, which will result in the Young modulus of wire Y to be less than of wire X. So this was the answer for this part. Let's move on to the next question. So the next question says a stationary wave is formed on the string xy. So this is the string sy and a stationary wave is being formed here. It has a length of 0.48 meter. Show the string at a instant at one time. So now they are telling us on the figure 5.1, draw a cross at a one position that is a node and another cross at a one position that is an antinode. Label the node N and the antinode A. So as we know, these points that lie on the mean position are the nodes. So they have told us to label anyone. This is the node and this is going to be an antinode. So easy one mark. So show that the wavelength of the wave produced is 0.32 meter. So let's just divide it the wave into the parts. So this is 1 over 4 or 0.25 lambda. This is another 0.25 lambda and this is another 0.25 lambda or another 0.25 lambda, or you can just say it is 1 lambda from this point to this point, and this is another half lambda. So 1 lambda and plus half, so it becomes 1.5 lambda. So 1.5 lambda is equals to 0.48 meter, which they have given us. So what is lambda equal to? So you can do this by cross multiplication. So 0.48 divided by 1.5. So it comes out to be 0.32 meters. Now in the third part, they are requiring us to calculate the frequency of the wave. So now how can we calculate the frequency? Now let's see, they have given, we have calculated the wavelength to be 0.32 meter, while the frequency requires either the time period or the speed must be given. Let's just check if there is speed. Yes, they have given us the speed. They have given us the speed. The speed of the string is 1400 meter per second. So we can use this. So we know that speed is equals to f lambda. So speed is 1400 meter per second into the frequency and into 0.32. This comes out to be the frequency will result to be 1400 divided by 0.32 and it comes out to be 4375. So rounded off to the next two, rounded off to the two significant figures, it comes out to be 4400. So you can write it as 4400 hertz. Now the B part is from the Doppler effect. A sound is of the source of a sound waves of frequency 780 hertz is on a rotating platform. The speed of the source is 39 meters per second. So this is the source speed and this is the source frequency. This is the source frequency. Let's just re-highlight this, and this is the source frequency. So the speed is 39 meter per second. The sound is detected by the observer that is a larger distance from the rotating platform as shown. So the speed of the sound in the air is 320 meter per second. The maximum frequency of the sound detected by the observer. They are requiring us to calculate the maximum frequency. So maximum frequency means the the least wavelength. So the maximum frequency will be observed when there is the least wavelength. So the least wavelength is observed when it is coming towards you. It is coming towards the observer. So we will use the formula F observed is equals to V into the multiplied by the frequency of the source and then V minus Vs. As it is coming towards you, we use V minus Vs, and if it coming going away from you, we use V plus Vs. So the F observed, which is the maximum frequency that will be observed, is equals to V of the of the sound 320 and then 320 minus what was this, the speed of the source, it was 39, and then It was the frequency of the source was 780 Hz. So let's calculate this. F observed becomes 320 into 780 divided by 320 minus 39. So this comes out to be 281 Hz. This is the maximum frequency that will be heard. So now they are telling us at time t0 the observer detects the sound emitted by the source when it was at the position shown in figure 5.2. This was the time 0, and on the figure 5.3 we have to sketch the variation of the time with the frequency of the sound detected by the observer from one complete rotation of the platform. Calculations are not required. So now what we have to be observing here is that at this point, at this particular point, it is the closest to the observer. This is the closest point, and the frequency here will be the maximum and the wavelength here will be the lowest. While on this particular point, what will happen? The frequency will be the lowest and the wavelength will be the highest, as it will be the most farthest. So at time t0 it is here, so the frequency will be the highest from the mean position. So first of all what we will be doing is that we are going to be drawing a line here. This is the mean frequency, or you can say the frequency that of the original of the source frequency. So the mean frequency, and the maximum frequency will be at time 0, and then after like as the rotation is being completed and it is moving away, the frequency will decrease and it will come to a minimum value. So this will be above and below the mean frequency. Mean frequency not originally means the original frequency of the source, but it means like the average of the two frequencies. So this was for this question. Now in the sixth question they are asking us to define resistance. So what is resistance? Resistance is the ratio of voltage and current, or you can say voltage divided by time. So now in the B part, a cylindrical metal wire of length 2.4 and cross-sectional area is 8 into 10 power minus 6. It has a air resistance 0.3 ohms and there is a current of 4.7. So we have to determine the resistivity. We know the resistivity formula. R is equals to rho L over A. So R is given as to be 0.33. Resistivity we have to calculate. The length is 2.4 and the cross-sectional area is 8 into 10 power minus 6. So we were just plugging in the values into the formula. So 0.33 into 8 into 10 power minus 6 and then divide by 2.4. So resistivity comes out to be, just put these values into the calculator and it will give you the result. So this comes out to be 1.1 to 10 power minus 6. 1.1 into 10 power minus 6, it is exact answer. So calculate the charge that passes through the wire in a time of 5 minutes. So now you have to be careful here. The current is charge passing per second, not per minute. So first we have to convert this into seconds. So it becomes 5 into 60. So 5 6 are is 30 and it becomes 300 seconds. So current is charge passing per minute time. So current was given us to be, it was 4.7 ohm 4.7 amps. So 4.7 amps into 300 is equals to the charge. The charge comes out to be 4.7 into 300. It is 1410 coulombs. So this was the answer of this part. The free electron charge carriers in the wire has an average drift speed of 0.16 millimeter per second. So now the unit is given as the speed is given to be millimeter per second. So convert it into the meter. It will become 0.16 into 10 power minus 3 meter per second. Okay. Determine the number density of the charge carriers in the metal. So we have the formula I is equals to E NEAV. So the current was 4.7. The number density of the charge carriers is unknown, and the elementary charge is 1.66 into 10 power minus 19. The cross-sectional area was given as 8 in 10 power minus, let's check it, I have forgotten that it is 8 in 10 power minus 6. Okay, so 8 in 10 power minus 6, and then into the drift speed. So 0.16 into 10 power minus 3 meter per second. So the number density comes out to be, just plug in all the values into the calculator. 1.68 10 power minus 90 into 8 into 10 power minus 6, and then 0.16 into 10 power minus 3, and this is going to be divided by 4.7, 4.7. So this becomes 2.2119 into 10 power 28. So we can write it as two significant figures to 2.2 into 10 power 28. So this is the number of charge, is number density. So this part is also done. The wire B may considered to be a fixed resistor. It is connected in series with a thermistor to a battery that has a negligible internal resistance. So what we have here is the wire may be considered to be a fixed resistor. It is connected in series to thermistor with a thermistor to a battery. So we have to draw a thermistor and a battery. So it is connected in series with a thermistor. Here comes the thermistor here, or you can also draw it in the other path. So this is the thermistor, this is going to be a thermistor, and this is going to be the path. So the battery in series with the thermistor. So was the circuit diagram for this part. Explain without calculation how the power dissipated in the wire changes as the temperature of the thermistor is increased. So you know that the the thermistor resistance decreases when the temperature is increased. So when this will happen, the resistance decrease, the current in the wire will increase, and the power dissipated in the wire, as you know, power in series circuit is power is equals to I square R. So power is directly proportional to I square. So as the as the current is going to be increasing, the the power is going to also increase. So we can write it here as when the temperature increases, the resistance of thermistor decrease. Hence, there will be more current or larger current. So power is directly proportional to I square. Therefore, resulting in larger power dissipation. So this was the answer for this part. Let's move on to the last question. Complete table 7.1 to show the charges in terms of elementary charge. E on each of the flavors of the quark and anti-quark shown. So the quark charge of the up quark is plus 2 by 3e, and the anti-quark will be minus 2 by 3e as opposite. The down one is minus 1 by 3e, and the anti will be 1 plus 1 by 3e. The strange is minus 1 by 3e as well, and the anti will be plus 1 by 3e. So easy 3 marks. State the name of the class of the group of fundamental particles to which the baryons and the mesons belong. So it is hadrons. Compare baryon and meson in terms of their constituent particles. So we know that baryons consist baryons are always made up of three quarks, while mesons are made up of two quarks, and essentially a quark and an antiquark and an antiquark. Now the next part says describe the beta decay in terms of the fundamental particles involved. So we will write that what actually happens in the beta decay is beta plus decay is that a neutrino is being also emitted, and the proton number actually decreases as the up quark is converted into a down quark. So it is also from the fundamental particle. So we are going to be writing it. So uh, an up quark changes into down quark with the emission of beta plus decay together with a neutrino. So this will be the answer for the last part of this question. So we have finished the paper. So this was all for today. Tomorrow is your paper. Good luck for the paper, and we are all hoping for the best. I'll meet you in the next video. Till then, goodbye.